Okay, so now we can see. Okay, so going over again, we're talking about statistics vocabulary. Individuals are objects described by a set of data. They could be people, but they could also be things, animals. All right, and then the variable is the characteristic of the individual. We already used this term. The characteristic of the individual. That's the one that you're measuring. Individual. Okay, so in your project, some of you chose to measure the price or the distance from your house, and these are the variables.
People, animals?
Yeah, so individuals could be people, but they could also be things or animals. All right, there are two different kinds of variables, categorical and quantitative. Which one of those do you think is about numbers? Quantitative, right. Quantitative is the numeric one. Number characteristic. Categorical is called qualitative, so it's about a quality, like what color is it, or how big is it. Actually, how big is it is a number. What color is a good category? So qualitative. It's about a quality or a word characteristic. Not a number. Okay, a population is the entire group of individuals that we're interested in studying. Oops, entire. But when you study a population, it's often not realistic to get information from every single individual, so instead you take a sample. So a sample is the part of the population you collect information from. I'll pause after that so you can catch up. So when you do your project, you'll be using some of these vocabulary words. They won't all apply, but you'll have some. What type of variables do you think we're looking for in this project? Are we looking for categorical or quantitative?
Well, both.
If we have to make a graph from it, it's more likely to be what? Quantitative. It has to be something that we can put a number on so we can graph it. All right, we're going to do the first example together, and then I'm going to let you guys try the other two examples, okay? All right, let's get back to recording. Okay, a furniture maker buys hardwood in large batches. The supplier is supposed to dry the wood before shipping. Wood that is not dry won't hold its size and shape. The furniture maker chooses 5 pieces of wood from each batch and tests its moisture content. If any piece exceeds 12% moisture content, the entire batch is sent back. Okay, so the population is the entire group of individuals we're interested in. So what are we interested in here? Yes, all of the wood in the large batch. But what is the sample? So the sample is the part we collect info from. We collected info from how many pieces? From 5, right. So the sample is the 5 pieces that we collected info from. Okay, so I want you guys to try 2 and 3 and compare answers with your group.
An insurance company wants motors.
Okay. We're going to go over these, make sure you got them, and then we'll go to the back. Okay, let's quiet down. Still waiting? Thank you. I'm going to read through it real quick. An insurance company wants to monitor the quality of its procedures for handling loss claims from auto insurance policies. Each month, the company selects a sample from all auto insurance claims filed that month to examine the accuracy and promptness with which they were handled. Raise your hand if you have the population. Let's see. How about Aiden?
Alright, all the loss claims that were
All claims
Claims that were filed.
filed. Good. All claims filed. Okay. Raise your hand if you have the sample. I think a lot of you have it. Go ahead, Kayla.
The portion of claims each month.
The portion of claims each month that they did what with? So the claims each month that they examined. Good. Okay. So the sample is all of the ones that they looked at, that they counted. It says they selected a sample to determine the accuracy and promptness. So say, for example, there were 100 claims filed, but they don't want to look at all 100 of them. Say they looked at 10, and from those 10 they found that 8 of them were handled with promptness. So that's telling them 8 out of 10 claims are handled with promptness. They could then guess that out of 100, probably 80 were handled promptly. All right, next one. Your local television station wonders if its viewers would rather watch a local college basketball team play or an NBA game scheduled at the same time. It announces that it will show the NBA game and receives 89 calls asking to show the local game instead. All right, what would the population be that they're interested in? Yes?
The total number of viewers.
Yeah, all of the viewers. They're interested in all of the viewers. Okay, but they don't have information from all of the viewers. They only have information from how many people? The 89 that called. This is not a good sample because it's only the people who are complaining about what they chose, right? All right, but their sample is the 89 viewers who called. Who has a question before we go to the back? Okay, turn it over. Okay, when we have a histogram, we can describe the pattern with socks. Now, there's a histogram at the bottom of your page, right here. So this here can be described with something called socks. Socks stands for something. Stands for shape, outlier, center, and spread. You cannot describe all graphs with socks. If you look on the board, I made some graphs. Which one is a histogram? The one on the left or the ones on the right? The left. The left is a histogram because you can see the numbers on the bottom, and it's from 0 to 5 is a certain amount, from 5 to 10 is a certain amount. This is a histogram. The reason why you would not talk about the shape of a graph that's not a histogram, if you look at my colors of M&Ms, you could just switch the order of these easily. I showed you red, blue, green. There's no reason to analyze that shape because you could easily make it green, red, blue. A histogram has to be in a certain order, and so it does make sense to analyze that shape. So, SOX describes and analyzes a histogram. Which means it's going to have to be quantitative data. Okay. The shape is the overall look of the data, and so I drew you some pictures for how it could look. So a symmetric is kind of what you're used to seeing, like a bell curve is symmetric. So the symmetric graph has the peak in the middle. But not all graphs are symmetric. For example, your grades in classes. In classes, most of you get grades that are between 64 and 100. So most of your grades are in here, but a few of you might get grades that are lower than that. That would be this tail over here. So that would be an example of a left skewed graph. A left skewed graph, it points to the left, or it has a left tail. Sometimes left skewed is called negatively skewed. But we use the term left skew. And sometimes right skewed would be positive skew. But the term we use is right skewed. And the right skewed graph has a right tail. All right, any questions on those shapes? Alejandro, did you get that?
Yeah.
Excellent. All right, outliers is when you have an observation outside the overall pattern. You don't always have an outlier. Remember that you don't always have one. Okay. So for example, if I gave you guys a quiz and most of you got an A or B, but one of you just wasn't feeling really good that day and you got a 0, that 0 would be an outlier because everybody else had the A or the B. Okay? Luckily, you'd have a chance to redo things, but okay, center. Center is the middle of the data. You could describe the middle of the data with the mean or with the median. So the mean, you know, is the average. And the average is more affected by outliers. So when you see a tail over here, the tail is often caused by some outliers, and that's going to change the mean more than it's going to change the median. So the mean is more affected by outliers. All right, the median is the middle number, which means 50% of the data is below it and 50% is above it. So when you have a symmetric, your mean and your median are both in the middle. But when you have a skew, that skew pulls the mean more than it pulls the median. So your mean is pulled over a little bit. Your median is also pulled over, but not as much. Okay, over here, your mean is pulled over more than your median is pulled.
What does that say? Positive what?
So the right skew could also be called positively skewed. If you might find that in your readings. I will use the term right skewed more. Are there any other questions about what I've written so far? You guys are doing good. We're almost there. All right, spread tells you how spread out the data is. Okay, so you could do that with the range, which is the biggest number, max, minus the smallest number. Or you could do that with the standard deviation, which we're going to learn about more later. For now, if we use standard deviation, we'll just do it on the calculator. But this is the symbol for standard deviation. What's that? Oh, yeah. Pardon. So for now, we're going to do a lot more range than standard deviation, but you can use a calculator to find the standard deviation, and a larger standard deviation means the data is more spread out.
Most better.
All right, so we have this one example to do, which is going to tie us in very well at the end of class. We're going to use socks on this example.
I didn't see that.
Okay. Talk to your group real quick. Tell your group if you think that that is symmetric, left skewed, or right skewed. Tell them. All right, raise your hand if you think it is symmetric. Who thinks this graph is symmetric? Who thinks this graph is left skewed? Raise your hand if you like left skewed. And who thinks it's right skewed? Put your hand up if you think it's right skewed. All right, you guys did great. It is left skewed because it has a tail on the left side. See how you could like draw it in like that? So this is left skewed. Oops. Left skewed. Okay. Next one is outliers. Do we have an outlier? We do have one data point that's really far from the others. It looks like it's about what number? So outlier at about 23. Okay. Looking at this, it would be really hard to find the mean. You could find the median by counting in. So if you were to count in all of these points, we would find that the median is about 90. But another thing you could tell me about the center is that because we know that this is a left skew, we know that the median is greater than the mean.
Good morning, teachers. Please bring your classes to attention and turning to the Seahawks field.
All right, and for the spread, we're going to find the range.
Wait, can you go down a little bit?
Yeah. So the range is the largest minus the smallest. What do you think the largest is?
107.
About 107. So 107 minus 23 gives us what range? 4? Okay. All right, guys. I'm going to stop that there. Let's see.